appreciate that. And we'll pick up here at the end of 1.3. So last page here was characteristics of the function, and then the next page is the same thing. I know I did this last bit very quickly, especially part C. I know we were right at the edge of class. It said when f of x equals 0, find x, or sorry, part D. What am I talking about? When f of x equal to 3, find x, and we ended up with a set where I had an interval and a single or a set of listed data. And I just want to make sure that was comfortable. The 2.9 is me being a little bit of a stickler because it's definitely not crossing this y equals 3 when x is equal to 3. Because if it were, it would be a horrible example because you don't know which 3 it is. It's your first introduction to it. So this is why we said this point right here we think is 2.9 comma 3. So that's where that set comes from, and that's why you see that notation. And then the x-intercepts and the y-intercepts all correspond. The x-intercepts correspond to when f of x is 0, because we know that's the case. Because whenever I have an x-intercept, my y is always 0. My y-intercept always corresponds to when x is 0. So we let x be 0, and we find that y is 3. But notice I don't have an equation for this function. I just have a graph. So we can't do this algebraically. So when do I have a y-intercept? When x is 0. When is x 0? All the points on the y-axis are where x is 0. And then you look, and where does it cross? It crosses at 0, 3. Remember, you'll have a maximum of one y-intercept on all functions, because if it crossed the y-axis twice, then it's not a function. All right, so we're gonna warm up with one more of these and finish 1.3. I'm gonna show you a little bit on domain and range for algebraic. So same concept as the last one, where evaluate f at -2. So for part A, f at -2, where is that? If I make this too large, when I print the screen, it takes up the whole screen, or it makes everything, or it makes 2 pages. So where is f? What is f at -2? Go to our graph. X is -2, y is 1. Now, here's what I want you to think about. And this is I've been batting this around for a couple days, trying to make sure you understand it. Inside this function is original notation is f of x, or as it says down there on the graph, y equals f of x, right? So when you plug in -2 for x, there's our notation, y equals f of x, that's just function notation. When I plug in -2, I'm plugging that in for x, right? What does x equals -2 look like on a graph? Does anybody know? What does x equals -2 look like? All right. I'm going to show you this, and then if it doesn't work for you, don't worry about it. But I've just kind of been throwing this around. So it turns out x equals -2 is actually a vertical line. Yeah, exactly. It's a vertical line when x is -2. So if you're ever looking at these and you're trying to figure out what do they want me to do when, f at -2, what does that mean? Well, it means when x is -2, where do you hit the curve? or where do you hit the graph? Not the X or Y axis, but the actual graph, the picture, the graph of the function. So when I put X equals -2 on the graph, it's super easy to see, oh, it hits right here when Y is 1. All right, so if that helps, what you could think of it as is I have a vertical line, and then I have Y is equal to some function, and the answer in both cases, I can consider this for cases when I'm given X, and I can consider this for cases where I'm given Y. I either have a function and a vertical line, or a function and a horizontal line, and I'm looking for the intersection. Where does this intersect with our function? And that's where we find our answer. So let's take that idea and move along to part B. And again, like I said, if that doesn't make sense, ignore it. Ignore everything I'm saying right now. So f at 4, I'm gonna come over here to when x is 4. I'm getting bounced around. So let's do it again. And again, I'm going overboard, I know. But when x is 4, where do I hit? Okay. Well, it turns out I don't. Can't get it to land right on top of it. But when x is 4, if I run down, and remember I'm giving this vertical line, I'm like, okay, where do I hit the graph? Well, when x is 4, if I go straight down following that line, I hit an open circle. An open circle means that endpoint is not included, right? So that means f at 4 is not defined. Okay. And why is it not defined? Because for no matter where I go on that vertical line, x equals 4, I never hit the function. All right. So for part C, I gotta use the thicker pen here. There we go. For part C, find all x for which f of x equals 3. Well, remember my notation, f of x is just a fancy y. So this is saying when y is 3, find x. What does y of 3 look like when I graph it? It is a horizontal line. So there I am. And where do I hit the graph? I hit the graph, or I intersect these, my horizontal line and my graph intersect at the point -4, +3. They wanted, in this question specifically, all the x's where this happens. Well, there's only one. It only hits the function once, and that is where x is -4. For part D, all x for which f of x is 1. Again, when is y equal to 1? If I go down to my graph, or go over here to my graph and take a look, when y is 1, I've got an entire interval here. I don't just hit once, I hit all the way across. So that starts at -3, and it goes until -1. And then whenever I got an interval, first thing I'm going to do is figure out the endpoints, and then the second thing I'm going to do is figure out, do I include the endpoints? The only time the endpoints are not included is if there's an open circle at those x values. And for both of these, there's not, right? So it looks like I start the f of x starts to return 1 when x is -3, and it continues doing it until x gets to -1, and then it stops. So endpoints are included. Okay. I guess the notation up here, I'm not trying to be the notation police, but we want to be consistent. This is actually the right answer because x equals -4 is a line, but that's just me being notation police. Just making sure that I stay consistent. So if you're learning the process or learning the language, that I stay consistent. So all the x's where y is 3, it's just at -4. All the x's for where y is 1, that's a whole bunch, and they're all the numbers between -3 and -1, including the endpoints. Part E, find the x-intercepts. That's going to happen when y is 0. So when is y equal to 0? Whenever f of x is equal to 0. When is f of x equal to 0? Okay. Well, that is the what? That is the x-axis, right? For all the points on the x-axis, the y-coordinate is 0. And where do I cross? Well, it looks like I cross that x-axis at the origin. Okay? So the origin is a point, and it is the point 0, 0. Okay? Notice I don't have x as an element of or y as an element of. I just have an ordered pair. Okay? So that's my x-intercept. You're only ever going to have one of those, because if you have multiples of those, or sorry, the y-intercept you're only going to have one of. So where's my y-intercept? Y-intercept is when x equals 0. Or in other words, f of x equals what? Okay. Well, where's the y-intercept? Well, I only get one of those, and where is it? It's the same place. Whenever you have, this is the only time these are going to repeat. If you cross at the origin, then your x-intercept and your y-intercept are going to match. Okay, there may be more. There may be more than one x-intercept. But if you ever have an x-intercept of 0, 0, you're going to have the y-intercept at 0, 0. If you have the y-intercept at 0, 0, you're going to have the x-intercept at 0, 0. And the reason is the origin is the point where the x and the y-axis intersect. Right? So if I'm crossing one of them, I'm crossing them both at that point. How about domain and range for these? So for domain and range, we're looking at all the x values that are possible, all the y values that are possible. If I take a look at my graph goes, if I'm reading it left to right, I'm coming down from positive infinity, and I follow, stop, and then I have an open circle right there around the point 4, -4. So where are the x values that work for this? Well, they start at -infinity, right? If that behavior continues forever, x is going to continue moving to the left and up forever. So what are the x values? Well, if I'm reading left to right, this little arrow means I'm starting out at -infinity, and I'm continuing. All these x values are defined, right? If I pick any x value in here, I do hit the graph with that corresponding vertical line. I continue and continue and continue and continue and continue, and then I stop when x is when x is +4. Because when x is +4, y is not defined. Even though I know that if the pattern continued, I would have a point 4, -4. I don't continue. I stop there because it's an open circle. So this means my domain starts at negative infinity and goes until I reach 4. Infinities are never included, all right? So that's why they always get a parenthesis. And the positive 4 doesn't get included because the endpoint is open. All right, so whenever I'm looking for the domain, I'm looking for, in essence, all the values of the function where if I draw a vertical, all the values of x where if I draw a vertical line, I hit the graph. For the range, instead of doing it for x, I do it for y. So starting at the bottom, I don't have -4, but I do have everything greater than that. So the range continues, right? I'm coming over here. Range is going up. I'm still hitting it. I'm still hitting it. I'm still hitting it. And it continues forever, right? So for the y-axis, I start at -4 and I run until forever. The range, and remember the range is the y variable, all the possible values of y. Pick up at -4 and run to positive infinity. Infinities never get a bracket because they're never included. -4 also does not get a bracket because there's that open circle. All right, so there's domain and range. Graphically, they can be a headache, but these are important concepts. So this is G and H. All right. Now, when they're graphed, the domain and range are pretty simple to find because you just look at the graph and say, oh, there's a hole there, or it stops here, or it has this behavior, and then you just write it down. What about if I gave it to you graphically, or excuse me, algebraically? So what I've got is I've taken what was page 7 of your notes and moved it to the end, and then I've added these 4 functions. I want to introduce you to the guidelines for finding the domain when given a function in an algebra, or when you're given a function, not the graph, but the actual function. All right. There are 2 things you cannot do in this class or in this section. The first one is you cannot divide by 0. And the second one is you cannot take the even root of a negative number. So no division by 0. That one's really straightforward. All right, and then the second one is no even roots of a negative number. Now, we have done that, right? We've seen imaginary numbers. We've seen complex numbers. But for this section, we're looking at the graphs of the function, and it's graphed on just the plain old Cartesian plane where x goes from negative infinity to infinity, y goes from negative infinity to infinity. So what's not on that graph are complex and imaginary numbers. So for the sake of this section, if you end up with a negative under an even root, we ignore all of the complex solutions. All right. So if these are the 2 rules, these are the 2 things that tell me the domain of everything. I can't divide by 0, and I can't have a negative under an even root. The only way I'm going to divide by 0, let's instead of making it some sweeping generalization, instead of looking at it as here's the big rule, the only way I'll ever divide by 0 in a function is if x is in the denominator. So when I'm trying to figure out part 1, I ask, is x in the denominator? And the answer for the first one, I'm going to write demon, okay? Denominator. All right, so is x in the denominator? Yes, yes it is. Okay, when there's a variable in the denominator and I and I don't have a domain, there is a value of x that's going to cause that denominator to be 0, right? So whenever x is in the denominator, to find or to remove all of those nasty answers that I don't want, I take the denominator and I set it equal to 0 and then solve. What I'm going to find are all the x values that make the denominator 0, which is the thing we have to avoid. So 2x minus 5 is equal to 0. Add 5 to both sides. 2x is equal to 5. Divide by 2, divide by 2. And x is 5/2. Now, this is a number that cannot be in the domain, right? Because if I plug in 5/2 to x, I don't care what the numerator does, the denominator goes to 0, right? 5/2 times 2 is 5, 5 minus 5 is 0. So 5/2 is removed. So there's half of the rules. I have removed the chance of dividing by 0. There's no other way the denominator is 0. So then the second part is I can't have the even root of a negative number. So then my second question is x under an even root? And the answer in this case is no. There's no roots in this problem at all. So I don't have to worry about rule 2. Rule 1, I've taken care of that. Rule 2 is not a problem. So what is my domain? Well, my domain, so if I write it, the domain is everything except 5/2. Right? Everybody agree to that? Everybody think that's true? No other rules were problems? So everything except 5/2. What does that look like on a number line? All right, well, it looks like here's 5/2, and the domain starts at negative infinity, goes all the way up to negative 5/2, stops, does not include it. I hop over it, I pick up on the other side, and I go on in that, I go on to the positive direction forever. So this is, that arrow represents negative infinity, this arrow represents positive infinity. So what does my domain look like if I'm going to write this in interval notation? Well, I start at negative infinity. I go all the way until I reach 5/2. I hop over 5/2, and I go to positive infinity. The 5/2 are the endpoints. It's the right endpoint on the first interval, it's the left endpoint on the second interval. Notice both of them have parentheses because all of this work is to get rid of 5/2, just 5/2. When my intervals are unique, when I have multiple intervals, I have to put them together with an and that and is a union for us. Everybody okay with this concept, right? If the denominator were allowed to be 5/2, I would divide by 0, which breaks the universe and causes black holes. We don't want that to happen, so we have to remove it, and this is the way you remove it. If you have to remove a single point from a domain, writing an interval notation looks like that, okay? If it were in set builder notation, we would say x such that x is a real number and x is not equal to 5/2. That's another way to write it. So if you run into set builder notation, I want you to realize that's what you're looking at. Okay. Number 2, or g of x over here. First question, is x in the denominator? Yeah, sure is. So what do? I take the denominator, set it equal to 0, and I solve. Subtract 4 from both sides. X squared is equal to -4. I have the square. I have x squared is equal to -4. I'm going to use square root property. And now I have x is equal to positive and negative square root of -4. Uh-oh. Okay, what is that going to be? Well, the negative comes out as I, and the square root of 4 is 2. So this is positive and negative 2i. Okay? So I told you if x is in the denominator, there's always going to be some number that you can plug in for x that makes the denominator 0. In this case, those are complex numbers. So whenever I take the denominator, set it equal 0, if I find complex solutions or complex answers here, they weren't in the domain to start with, and I need to remove them, right? My domain is -infinity to infinity. It's all the real numbers. These are complex. So this changes nothing, right? They were not part of the numbers I was considering anyway. So since complex already considered. All right, so that means the domain, if I don't find any problems, the domain is understood is automatically all real numbers, which in interval notation looks like that, and in set builder notation looks like that. -infinity to infinity. There are no real numbers that make me divide by 0 or leave a negative under an even root. Okay. Let's get the last two. On the bottom left, h at t is the square root of t, 2 minus t. Oh, wait a second, sorry. I didn't do the second part. That's because I already knew the answer. The second question is x under an even root, and the answer is no. So that means I don't have to worry about that step over there. So step 1 is x in the denominator. Yes, work it out, figure out what's included, what's not included. Then come back to the second question, is x under an even root? No. So we don't have to worry about that one. So let's take that process to exactly what same thing, let's just do it for h at t. So in this problem, the variable is t, so I say is t in the denominator. And for the first time, the answer is no. Okay, so if it's not in the denominator, I don't have to worry about, I don't have to take the denominator, set equals 0 and solve. But now is t under an even root? And the answer is yes. Okay. So when this happens, what I need to do is guarantee that what's under the even root stays positive or 0. I just cannot let that be negative, right? What's under the root cannot be negative. So if I say something, if I wanted to say mathematically, how do you say mathematically that a algebraic, that a great expression cannot be negative? How do I say that? Or let's translate to math. All right. So if it can't be negative, it can only be what? What are the only other possibilities? If what's in there is not allowed to be negative, that's an algebraic expression. Okay. Y is less than 0. Okay, so y is less than 0. So that's all the values that are negative. So if those are not included, what values are? Good. That's all right. So I said what's under the root has to remain positive or 0. So I literally take what's under the root, it's called the radicand, and I say, okay, 2 minus t remain positive or equal to t minus 2 minus t greater than or equal to 0. It's always the radicand, so it's always what's under that even root. And then I solve this. All right, so solve this, and what do we get? I'm going to subtract 2 from both sides. And the reason I'm doing that is I don't want the t to get on the wrong side. Subtracting 2 doesn't cause any issues, but dividing t is not by itself. It's still got a sign, a negative sign with it. So I need to divide both sides by -1. And in doing so, I flip the sign on both sides and I flip the direction of the inequality. So t is less than or equal to 2. Okay? When you have this encounter, when you deal with a variable under an even root, this is the domain, except issues with the step 1. All right, so in those top 2 problems, whenever I determine what makes the denominator 0, the answers to that question are not in the domain. Whenever I'm dealing with this, 2 minus t is greater than or equal to 0, what I end up with is the domain minus any problems where I get division by 0. So what's my domain here? It's everything less than or equal to -2. Everything less than or equal to -2 means start out at -infinity, go all the way to 2, and include it. Okay, number line, here's 2, everything less than that, forever. 2 is included because it's fine if what's under the root is 0. It's just once it goes negative that we have a problem. All right. And then lastly, absolute value. Okay. Now, this is going to sound, I don't mean this to sound, I don't even know what it sounds like, but here's the thing. I've got the absolute value. People know there are problems. People know that I have some rules. So everybody starts looking at this and they're like, okay, wait a second. This is only this. No, don't look at that and try to add a new rule or make something up. Don't think, oh, well, absolute value only returns positive numbers. So that, no. There are 2 questions you ask for domain. Is the variable, and for this it's a, in the denominator? No. The last part. Oh, sorry. I'll come right back to it. Is a under an even root? No. If the answer to both of your questions is no, then the domain is automatically all real numbers. If the variable is not in the denominator, if the variable is not under an even root, the domain is all real numbers. Because there's no value of a that breaks those 2 rules, either of those 2 rules. I cannot get an a that causes division by 0. I cannot get an a that is under an even root, because there is no denominator here, and there is no even root. Okay? Questions. Again, the questions usually come with doing the homework, obviously. So if you haven't gotten this far in 1-3, if you haven't looked at the homework, get in there. Make sure you're feeling that you feel comfortable with this material. Do some examples, and then bring questions if you have them. All right. So we'll jump on to 1-4 and get through this relatively quickly. Linear equations in two variables in linear functions. Okay, two variables. We've been doing this for a while. Linear equations with two variables. I have a dependent and an independent variable. Typically, the dependent variable is x, the independent variable is y. And we see a graph right here with yearly median yearly incomes by level of education. And y-axis has median income in money, in dollars, and the x-axis. Notice it's not the years, but it's the number of years since a given year. So in the bottom denominator, not denominator, on the bottom on the y-axis, x-axis there, you see 0, 5, 10, 15, 20. That's not the years 0, 5, 10. That's 5 years after 1990, 10 years after 1990, and so on. So you can see as time progresses, both people seem to be getting raises, right? Their income is increasing, but the bachelor's degree started higher and is rising, and so it started higher and it's ending higher. The line that represents the number of years for a high school degree and the job is rising, but it's rising slower, and it's not going to rise as high. Okay, so these equations that represent them are linear equations in two variables. I have an x and I have a y. So linear equations, we're going to get this formal definition out of the way. A, B, and C are real numbers. A and B are both not zero. Okay? And linear equation in the variables x and y can be written in this form. This is called the standard form. AX plus BY is equal to C. All right, that's the standard form. That is not a particularly useful form for us. We would rather have slope-intercept form or point-slope form, but that is the standard form. If you're in linear equation in two variables, then you can be written in that form. And this is why A and B are not allowed to be zero. C can be zero because I don't really care what C is, it's just a constant. But if B is zero, the y goes away. If A is zero, the x goes away. So two variables, linear equations. And my little note down here, whenever I write my equation in standard form, it's typical that A, B, and C are understood to be integers, okay, not including zero. And A, B, and C have no common factors. So if you can get a linear equation, if you've got a common factor in there, you usually just divide it off of both sides, and you're going to end up with an equation that looks like that. AX plus BY equals C. A, B, and C are real numbers, and they are understood to be integers. All right, so that is a linear equation. What about slope? Okay, slope is literally the rate, and we're going to get specific here, the average rate of change for the y variable as the x variable increases. All right, so for every unit to the right we go, or to the left we go, how far up or down did we go? So in the graph, in the picture down here, the blue line, this blue line here is the graph of my function. And I've picked 2 points on that graph. I've picked x1, y1, and I've picked x2, y2. And the question is, what is the slope, or what is the change in y as x changes? Okay. The formula for this you probably remember. The change in y is literally y1 to y2. So this dotted line represents the change in y. And then the x values, this is x1, this is x2, the change in x values from here to here. So how do I represent these lines? All right, well, change in x is my horizontal dotted line. Change in y is my vertical dotted line. And if I want to know what is the average rate of change of y in terms of x, then I end up with this equation. For notation's sake, you'll see this triangle. This is the Greek letter delta. And delta typically refers to change in. Okay? So we're saying the slope is equal to the change in y over the change in x. In other words, however long this vertical line is divided by however long this horizontal line is. How do I figure out how long those vertical and horizontal lines are? I take the y values and I subtract them. I take the x values and I subtract them, and then I divide the results of those, the differences that I have created. Notice that the points have, the x and the y have coordinate, or have subscripts. That is just to indicate that whatever point you let be x1, y1, whichever one you let be x2, y2, the location matters. So if once you decide, okay, this value is y2, the rest of the values are decided then, right? If y2 comes from this point, then x2 has to come from the same point. y1 comes from the other point, x1 comes from the other point. When we get an example, that will help with us, all right? So what is the slope of the line between these 2 points? I'm going to do the top 2, then I'm going to stop, and I'm going to let you do the bottom 2 and see what you come up with. All right, so slope, change in y over change in x. And what is that? y2. So for me, I always let the first line I encounter, the first point I encounter, be x1, y1, and the second point I encounter be x2, y2. I used to try to pick the ones I wanted to make the subtraction easier, but then I found I was always trying to remember, okay, if the y2 is from the first one, this one, the first one is y2, so the second one's the y1, and it just got to be a mess. So instead of doing that, it's just easier for me to always remember that the first point I run into is x1, y1, the second point I run into is x2, y2. So now my y2 is 3, my x2 is 2, it's subtract, and then my y1 is -3, and my x1 is -1. Okay? Why the parentheses? It's to make sure that we don't do a minus and negative, or make sure the minuses don't just run together. 3 minus -3 is 3 plus 3, and the denominator 2 minus -1 is 2 plus 1. So end up with 6 over 3, which is 2. All right, what does that mean? That is the change in y over the change in x. So a slope of 2, we have to remember that our all of our fractions, all numbers can be rewritten as fractions. So a slope of 2 means that the line passing through these, through the points, increases 2 units in the vertical direction for every 1 unit increase in the horizontal direction. In other words, y changes 2 units, x changes 1 unit. So what I said was, and I'm just going to rewrite the 2. This is the slope of 2, which can be rewritten as 2 over 1. So the y changes, remember, the denominator is change in y, or the numerator is change in y, the denominator is change in x. So 2 over 1, change of 2 units in the y direction for every 1 unit in the x direction. Both of these are positive, so that's why you that's why you see me saying units in the vertical direction and in the horizontal direction. So I go up 2 and then right 1. All right, so there's my slope. Anytime you get an integer for the slope, just always remember that that is itself over 1. All right, so what about the next problem? Change in y or change in x for these 2 points, x of 2 minus x of 1. Again, it's just easier for me to always let my second point be the x2, y2. My first point is the x1, y1. So I got 4 minus 4 over 2 minus 1. 4 minus 4 is 0. 0, 2 minus 1 is 1. 0 in the numerator is absolutely fine. All right? So if a slope of 0 divided by 1 is just 0. All right? So my slope is 0. What does that mean? Okay. Well, remember the slope is how much do I change in the vertical direction for every unit of change in the horizontal direction. This says I don't change vertically at all. So if I take those 2 points, 1, 4 and 2, 4, and I plot them on a graph, they're going to be in a horizontal line. All right? Because what are they both, what matches in both those points? The y coordinate, right? Both of them have a y coordinate of 4. So if the y coordinates are both 4, that means I don't move up or down when I try to go from 1, 4 to 2, 4. All right. So you take your minute and see what you can do with these 2. And then I'll, yeah, and then we'll come back. We'll just come back and knock out as much as we can. So tell me what you get. All right. So for first problem down there, I've got a slope that's undefined. Okay. And it's undefined because following the directions causes me to divide by 0. All right? You cannot divide by 0. It is not allowed. So that means my slope is undefined. So what does that mean? Well, graphically, take a look at these points. They share the same x value, right? So both these points are on the same line, x equals -3. X equals -3 is a vertical line. Slope is trying to tell you how many places do I move left or right for every, or how many places do I move up or down per left or right move. This is a vertical line. It just keeps going up. It never moves left or right. Okay? So that is why this is undefined. A slope of 0 and a slope that is undefined are not the same thing. They're different things. All right, so keep that in mind. For the other one, we finally end up with our a fractional slope. And not only is it fractional, it's also negative. All right, so the slope is -3/4. Now, you can write this a couple of ways. You can write this as -3/4. You can write it as -3 divided by 4. Or you can write it as 3 divided by -4. Whenever I need to apply it, I typically let the numerator be the negative and the denominator be the positive. And the reason for that is if you try to apply that negative to the numerator and the denominator, what you'll do is you'll actually end up dividing a negative by a negative. The whole fraction will turn out to be positive. So either whenever you're trying to determine what am I doing here, always either put the negative with the numerator and let the denominator be positive, or put the negative with the denominator and let the numerator be positive. Because if they're both negative, then -3 divided by -4 actually comes out to +3/4. All right. So that is finding slope. Questions? Concerns, issues, anything? All right. No? All right, so let's talk about this application problem for a BMX bike. BMX bike's jump height in inches is linearly related to its weight in pounds. If a 20-pound bike has a jump height of 10.25 inches and a 24-pound bike has a jump of 9.6 inches, find and interpret the slope of this relationship. All right, so I have 2 data points. And they seem to give me some information. They imply something is happening here. I have a 20-pound bike with a 10.25 inch jump height. And I have a 24-pound bike with a 9.6 inch jump height. Now, whenever you get an application problem for this section, there's always an issue. And the issue is, if I'm going to find the slope, I have x values and y values. Which one is x? Which one is y? So the answer to that question is, which one is dependent on the other? Which is x, which is y? The y value is dependent on the x value. So when you find a relationship, find this linear relationship, what you're looking for is one of these numbers is heavily dependent on the other one. So Andrew's saying y is height, x is weight. Does everybody agree with that? Yeah, so the height of the jump seems dependent on the weight of the bike. All right, I have two bikes. The heavier bike that jumps lower has a lower jump height than the higher, or than the heavier bike. The heavier bike has the lower jump height. The lighter bike has the higher jump height. So for us, that means the weight of the bike is going to be x, and the height is going to be y. So the weight of the bike is x, height, jump height, let me type it correctly, jump height is y. So that means these two data points are actually the ordered pairs, what? 20, 10.25, and 24, 9.6. And they've asked me to find and interpret the slope in this relationship. Slope is the change in y over the change in x, which is 10.25 minus 9.6 over 24 minus 20. 24 minus 20 is obviously 4. And the 10.25 minus 9.6 in the numerator gives us, it comes out to negative 0.65 divided by 4, which is negative 0.1625. 9.6 is with the 20. No, the 9.6 is with the 24, yeah. Mm-hmm. Mm-hmm. Yeah, y2, y1, x. Nope. You caught me. What did I do right? Oh my God. It's going to be one of them days. Got ahead of myself again. All right, let's keep the rules that I said. Thank you for catching that. All right, so the first point is x1, y1. The second point is x2, y2. So y2 is 9.6. y1 is 10.25. Right? x2 is 24. x1 is 20. So now I have, yeah, my sign was wrong, but that is correct now. Negative 0.65 over 4, which when divided out gives us negative 0.1625. Okay? So what does that mean? Well, this is an application problem, so I can actually get the units. Yeah, no, I had the top flipped. You were right. Right, so what does this mean in terms of the problem, in terms of a general problem? Well, this means for every increase of 1 unit in the x direction, I decrease the y by 0.1625. Okay, what are the units that I was dealing with? Well, y2 and y1 are inches, right? And x2 and x1 are pounds. So this is negative 0.1625 inches per pound, right? So if I had to say, what does this relationship mean? It would seem that we agree already that as I increase the weight of the bike, I decrease the jump height. This is the rate of that change. So the slope of negative 0.1625 means for every pound of weight bike added to the bike, the jump height decreases by 0.1625 inches. Does that make sense? How do we feel about that? How are we feeling about that? Does that make sense? Other than me screwing up the math there. Is that all right? If it's an application problem, yes. So Andrew asked, do we have to write this out every time? And the answer is yes. If it's an application problem, the answer would need to be written this way. All right. All right, so quickly tackle, I know we've got 4 minutes. I want to get you over to this next page and get you started. To graph a linear equation, you need a line. It's a straight line. And you've always heard that the shortest distance between 2 points is a straight line. So really all you need to do is find, if I want to graph an equation, all I have to do is find 2 points and then connect those. And then draw a line that goes through both of them. Sometimes, and just to be safe or check, or if you're having an off day and you're not sure, that you're not confident with your math, find a third point, make sure they all line up, and it'll help you. So we're asked to graph each of these equations on the line. On this graph, you're going to graph all 3 of them together. And I'm going to leave this for you to do. And we'll come back to this point. We'll come back to 1-4, pick it up right here on Thursday. And yeah, this is where we are. That's we're moving at the pace we need to move at, so I'm happy with that. Any questions before we call it a day? If anything is due, I know 1-3 is due next Tuesday. So 1-3 and 1-4 probably due next Tuesday. That's going to stand. But yeah, if something looks like it's due before we cover it in class, since we're behind, don't worry, I'm going to move those dates. All right? All right, well, everybody have a good rest of the day.